Welcome to Lesson 6, Elaboration. In this lesson, we'll use Chromosocks, a Hudson Alpha invention, to model meiosis. The beauty of this lesson is that students get to put their hands on something and to model meiosis, which, as you know, is a great learning tool, but also for formative assessment with students working with rather large spaces on their desks and in a very clear worksheet. You can see who's getting it and exactly what point those that are not getting it are breaking down. So that said, let's go over sort of an overview of how this lesson works. In this lesson, students do some background building about meiosis, and then get involved in what chromosocks are and are introduced to the sock organism. There's some clarification about our good friends, the chromosomes, what DNA replication means, and what that looks like with chromosocks. So students take these socks through the phases of meiosis, stopping along the way for you to check and make sure they understand it. And once students are comfortable modeling meiosis with these chromosocks, then they learn what might happen if meiosis does not go as planned. And rather than just talking it through or backing up one step, students start from the very beginning and model some of these situations that can result in mutations. So, and then there's an activity at the end for students to write a storyboard and illustrate it to go over what they've learned about meiosis. I do want to point out a few points of interest, points of confusion, or other kinds of tips before you take off to do this in your classroom. First, it's important that meiosis is not taught as just something like mitosis with a twist or mitosis with an extra division. Meiosis needs to be taught separately from meiosis, as they are two different processes with different end results. You studied mitosis back in Lesson 5 and learned that mitosis is used in cell division for organisms to grow and replace cells, and in unicellular organisms, mitosis is used as a reproductive method. Meiosis, on the other hand, is not about cell division or growth or repair. It is strictly, the purpose of meiosis is strictly to form cells with half the chromosomes, haploid cells, so that in fertilization, the cells of the organism have the correct number of chromosomes. Meiosis is the process through which sex cells or gametes are formed. In females, most of this is done before the baby's born or before the organism is an adult. In males, this is ongoing. Now, I invite you to go down rabbit holes and brush up on any of the lessons you may have forgotten from college about meiosis in women especially. It's fascinating business. But keep in mind your 7th graders are just now learning all this, so you almost have to work not to overwhelm them. I want to remind you that it's important that you read all the background information in your teacher edition so that you're prepared for the background information for your students. So if you have not done that yet, please stop this slideshow and do that now. As you begin your modeling section of the lesson and introducing using socks as chromosomes, you can point out to students that socks work well for this lesson because socks, like chromosomes, come in pairs. Now, there is a temptation to go ahead and start using the other set of socks you have, which will be used later in modeling Mendel's laws. Now, the other socks are labeled with different alleles. You don't want to use those in this lesson. It's important that students understand how meiosis works now before they begin working with the modeling Mendel's laws. So avoid that temptation. This is the point at which you introduce the word ploidy. And another very important term that you need to understand and we'll review here is duplication versus replication. Students are used to seeing this X shape and calling it a chromosome. They may not be comfortable with seeing just this bar shape and calling it a chromosome as well. And to make even things more confusing, this is one chromosome and this is one chromosome. Please go over and over and over that with your students. How many chromosomes? One chromosome. How many chromosomes? One chromosome. Well, what's the difference? Why isn't this two chromosomes? Well, it's still one chromosome, and when in doubt, count the centromeres. But this chromosome has more genetic material in it. We call this a replicated chromosome. We don't call it duplicated because that gives the idea that one chromosome has become two. And that's not the case. It's one chromosome has increased or doubled its DNA, or excuse me, its genetic material, it's DNA, but itself did not become two chromosomes. This may sound like a nitpicky point, but it is important when students are older in their biology classes and they're learning that organisms have a certain number of chromosomes. Humans do not ever have more than 46 chromosomes. All of our cells have 46 chromosomes except for our gametes, which have 23, which is the purpose of this lesson. So a lot of adults, and maybe you from your college experience, had the misinterpretation that we at some point during meiosis have 96 chromosomes, but that is not true. And if it were true, we would not be humans, or we would not be viable humans. One chromosome, one chromosome. Here's a nice picture of how your socks model replicated DNA. When students get to this point in their modeling, they'll need that second bag of socks. Now you can have them hide one sock under another and then slowly spread it out to form sort of a little X shape, or you can just keep them bundled, stacked up on each other. The rubber band is your centromere. But again, it's very important students call this one chromosome. Yeah, we know it's two socks, but let's not go there. Students use the socks and go through step by step with the worksheet in their book through the steps of meiosis 1 and meiosis 2. The best help I can tell you is to practice this. To practice it, go through writing your answers down on the worksheet, compare your answers to the answers in the teacher's edition, practice it again and again, maybe borrow a couple of students during extra time. Well, we all know about that extra time. If you're allowed to pull students during your planning, and go through and practice with students, practice with your husband or wife, they'll love that. There are a lot of points where it can become confusing, and the only way to really make it clear is practice. Your science specialist, your AmSty science specialist, can help you if you need help with this lesson. But again, it's just practicing before you go in your classroom to do this. We unfortunately have seen classrooms where teachers were getting this out for the first time and trying to do it with students, and trust me, it's a nightmare. All right, so once students are comfortable with meiosis, then we let them model these situations where meiosis does not go as planned, and they learn about problems such as non-disjunction. And in the book, there's a reading that tells what some of these situations really are. In the end, you have a video, the Amoeba Sisters presenting meiosis, and students are asked to draw a storyboard where they illustrate and draw pictures for the steps of meiosis. We hope you enjoy this lesson. It's fascinating and complicated, but worth learning, and your students will feel so accomplished once they can go through these steps without messing up. Hope you enjoy it, and we'll see you back for Lesson 7.